And welcome. We're going to look at some half-life problems, and half-lives are great. They're really useful things. They're used a lot in geology and in earth science and in medicine as well. And you can answer questions like this by using half-lives. So first of all, if we're going to use the if we're going to look at age of samples, you need to know this equation from previously. And if we're going to look at properties of a sample, what we mean by properties are things like how much of the different isotopes are in the sample, the parent isotope, the daughter isotope, and how radioactive is the sample. So, these are the two questions we're going to look at. Now, they seem quite simple, but because with radioactivity you can measure half-life in two different ways. You can look at the radioactivity of a sample as it decreases, or you can look at the mass of a sample as it decreases. You may get asked these two basic questions in a couple of different ways. So here I've put down the age of the sample. You can see both of these questions are asking you the age. The first one is asking you about the number of atoms of each isotope, so that's this graph. And the second question is asking you about radioactivity. It's the same thing here. One of them is asking you about the number of atoms of the parent or daughter isotope, and the second one is asking you about the radioactivity. So let's have a look at a couple of examples. We've got phosphorus here, and the question gives us some information at the top. I'll let you read that. So if we try the first one, try question A, the first thing we need to do is write down the count rate. So 100 counts per minute, and we know that after one half-life this will have halved to 50, and then after another half-life it will have decreased to 25. So each of these arrows here is representing a half-life. So it's asking us to find out how old the sample is. Now what we need to do is use the information we've jotted down here with the information in the question. We know a half-life is 14.3 days. So what we can do is use the equation we looked at the beginning, and then substitute in the numbers. We've got two half-lives, each is 14.3 days, so in total the sample will be 28.6 days old. There you go. So the next question, it says the sample is count rate is 60 but is 28.6 days old. So we need to work out how many half-lives the sample has gone through. So that's how old it is. That's one half-life. So in total this sample has gone through two half-lives. So what we can say now is, okay, it's 60 originally, here's one half-life, it's taken the count rate down to 30, after two half-lives the count rate's gone down to 15. So that's our answer. Now these examples were a little bit simpler. If you're looking at count rates, this is easier because we haven't got to try and consider the amount of parent to daughter isotopes. So for the next couple of examples, instead of just having one arrow coming off to represent a half-life, we're going to have two arrows coming off. So I'll show you what that means now. This is a very similar question. I'll let you read that. So it tells us the sample has 100 atoms of P32, so presume that this is 100% phosphorus 32, but now it contains 25 atoms. So what we're trying to show is that phosphorus 32, the 100 atoms of it, is decayed, so half is still P32, but the other half is decayed into the daughter isotope, that's sulfur 32. So here I'm trying to show that this half of the original parent isotope left, and the other half is decayed into a new daughter isotope. And we know that one half left, represented by these arrow lines, is 14.3 days. So after, go back to the question, it tells us we're looking for 25 atoms, so we keep doing this decay process till we reach 25 atoms. So here, remember that the phosphorus is the only radioactive isotope, So that decays again, and the sulfur 32 stays as it was. Presume that's not radioactive and it's still in the sample. So in total, you can see you've got 75 atoms of sulfur 32 and 25 atoms of phosphorus 32. So the half-life tells, the question asks us how old is the sample. We know it's undergone 1 half-life, 2 half-lives. We use this equation again, so the age of the sample is obviously 2 times 14.3 days, which is 28.6 days old. Okay, and last example, if the sample has 60 atoms, but is now 28.6 days old, how many atoms phosphorus would you expect it to contain now? So obviously we want to work out how many half-lives it's undergone, which is what I've done here, and then show, okay, we started with 60 atoms, after 1 half-life, half of it is decayed into sulfur, half of it is still phosphorus. After 2 half-lives, the phosphorus has decayed again. So in total we've got 45 atoms of sulfur 32, 15 atoms of phosphorus 32. Okay, right. So if that annoying little screen doesn't pop up again, hopefully you'll be able to practice that out and have a go at some of these questions yourselves. Good luck.